Have you ever wondered what the likes of architects, physicists, and engineers have in common, and what they use to construct the buildings and structures that they do? Well, the answer is right here on the board. Trigonometry. Hi guys, so today we're going to be looking at a topic that you might have heard before, you might have even seen it being mentioned somewhere, and that is the topic of trigonometry. Now you might be wondering, what is trigonometry? And where can we use it in real life? And will it ever affect your life, or would it ever help you or benefit you in life? Well, that's what we're going to look at today. So as we mentioned earlier, trigonometry studies the relationship between angles, which could be here, which is an angle of a triangle, and the side of a triangle, or the sides of a triangle. So a triangle, as you know, has three sides as well as three angles. So this can be written as a side. And the basis of trigonometry is based on right angle triangles. And for those of you who do not know what a right angle triangle is, a right angle triangle is a triangle with an angle on one side equating to 90 degrees. So we ask the question, where do we use trigonometry in real life? Well, trigonometry is used in various industries, and in some industries is even considered essential. And so let's look at 5 of the main industries in which trigonometry is used are engineering, architecture, aviation, animation, and even criminology, believe it or not. Now, of course, I'm sure for those of you who have had prior experience with the topic, you would know that it's very, very important in the likes of engineering and architecture and even aviation. And if we were to take an example of how trigonometry is used in the aviation industry, trigonometry helps in plotting flight paths, calculating angles for descent when the plane is about to land, as well as ascent when the plane is taking off, and also adjusting for wind speeds and direction during flight. Now, before moving further, we need to take note of one fundamental principle, and that is the Pythagoras Theorem. So suppose you have a right angle triangle and you have an angle theta over here, and we have the adjacent side to the angle, which is this side, as side A, the side opposite to the angle as side B, and the other side, which is known as the hypotenuse corresponding to the angle theta, as side C. The Pythagoras theorem states that the squared of the adjacent side, which is a squared, plus the squared of the opposite side corresponding to the angle, which is b squared, is equal to the hypotenuse side, side C squared. So for example, say you have a right angle triangle with a corresponding angle theta on this angle, and they've given us the value of the adjacent side corresponding to the angle theta as well as the opposite side corresponding to the angle theta. So let's say the adjacent side is equal to 3 units and the opposite side corresponding to the angle theta is equal to 4 units. And they're asking us to find the value of the hypotenuse. Let's call it x. So using the Pythagoras theorem, and inputting the values of the sides given, we would see that 3 squared plus 4 squared is equal to x squared, which is the hypotenuse side squared. Now 3 squared is simply going to be 9, and 4 squared is simply going to be 16, and that is equal to x squared, again the hypotenuse side squared. So some simple addition over here brings this to 25 being equal to x squared. So if we move this here real quick, in order to make x squared into x, what we're going to do is we're going to square root both sides. So we square root x squared will be square root 25. The x squared, the power 2, will get cancelled and become x. And root 25 can be written as plus or minus 5. However, since a length cannot be negative, x cannot be a negative value. So therefore, x, which is equal to the length of the hypotenuse, would be equal to 5. Now we look at trigonometric functions. Now, for basic trigonometry, there are three main functions which you would need to look at. The first one is sine theta, followed by cos theta, followed by tan theta. And we're going to use the same right angle triangle here to kind of showcase and make you understand the formula relating to the trigonometric functions. So if we take a right angle triangle again with the corresponding angle theta over here, and we have the adjacent side to the angle, let's call it A for adjacent, and we have the opposite side here corresponding to the angle theta, let's call it O for opposite, and of course the hypotenuse, let's call it H for simplicity. So the equations of sine theta, cos theta and tan theta are as follows. So let's take sine theta, that would be equal to the opposite side corresponding to angle theta divided by the hypotenuse. So the equation for sine of a given angle in a right angle triangle would be equal to the opposite side corresponding to the angle divided by the hypotenuse. And similarly, for cos theta, the equation is the adjacent side corresponding to the angle theta on the numerator, which is this, divided once again by the hypotenuse. And lastly, for tan theta, the equation on the numerator, we have the opposite side corresponding to angle theta divided by the adjacent side corresponding to the angle theta. So let's look at an example using both the Pythagoras equation as well as the trigonometric functions which we just learned. So let's say we have again a right angle triangle with the angle theta on this side, and they've given us the values of the adjacent side to the angle theta as well as the opposite side corresponding to the angle theta. So let's say the adjacent side is equal to 5 and the opposite side is equal to 12, and once again they haven't given us the hypotenuse side, we need to find it, so let's call it H for simplicity, and they've asked us to find the values of sine theta, cos theta and tan theta. So if you remember, for sine theta and cos theta, we are going to need the value of the hypotenuse side to find the value of sine theta and cos theta. So what we're initially going to do is we're going to use the Pythagoras equation in order to find the value of the hypotenuse side. So if we use the Pythagoras equation, we would see that the adjacent side squared plus the value of the opposite side squared is equal to the hypotenuse side squared. And if we substitute the values we have here into this equation, we get 5 squared plus 12 squared is equal 2h squared. So 5 squared is equal to 25, and 12 squared is equal to 144, and that is equal to h squared. A quick addition of this gives you h squared being equal to 169. And again, in order to find h, we're going to square root both the left-hand side and the right-hand side. So we get root h squared with root of 169. And again, we're not going to keep the plus or minus sign on the right-hand side because we're aware that the length cannot be negative. So we're going to have the hypotenuse side be equal to the root of 169, which is 13. So we can erase the h over here. We can put this as 13 now. So now how are we going to answer the question? They've asked us to find sine theta, cos theta, and tan theta. Well, we're going to use the equations for each of them, which we just learned before. So if we take sine theta is equal to the opposite side corresponding to the angle theta divided by the hypotenuse. So we write op for short here, divided by the hypotenuse. So the value of the opposite side corresponding to the angle theta is 12. So we can write 12 on the numerator here. And similarly, the value of the hypotenuse is 13. So we have an answer for sine theta, which is 12 over 13. And we're going to use the same approach to find cos theta and tan theta. So if we were to take the equation of cos theta as we learned, cos theta is equal to the adjacent side divided by the hypotenuse. So if we write it down here, we get cos theta to the adjacent divided by the hypotenuse. And if we look at the triangle, the adjacent side corresponding to the angle theta is equal to 5. So we put 5 on our numerator here, and our denominator, which is the hypotenuse, is going to be the same denominator we put in the sine equation, which is 13. So we put 13 over here. And we have an answer for cos theta, and cos theta is equal to 5 over 13. Finally, we use the equation for tan theta, which is the opposite side corresponding to the angle theta, which is 12, divided by the adjacent side corresponding to the angle theta. And if we input both values, we get a value of the opposite side being equal to 12. So we have 12 over here, divided by the adjacent side, which is 5. And those are the answers for sine theta, cos theta, and tan theta taken from this particular triangle. And with that, we've learned basic trigonometric functions and how to tackle any problem that comes your way using, again, the basics, the Pythagoras Theorem, and the trigonometric functions which we learned for sine theta, cos theta, and tan theta. And as I mentioned, using the knowledge we just learned here today, you should be able to tackle any basic trigonometric problem.